Now, getting down to precisely what's happening, and particularly in obviously the important upper horizon or the topsoil. And what we want to do is not just look at what is the impact of a herbal ley on the soil, but look at what is the impact in herbal ley in terms of the sorts of roots and the sorts of organic matter that it injects into the soil. How does that differ from what's been done for the last, gosh, how many years, which is a grass clover ley? So most livestock farmers, unless they've got permanent old grassland, will from time to time refresh their fields with a relatively simple mixture grass clover ley, which is great. It delivers happy fat animals, but these return, if you like, to a more complex herbal ley, which emulates the very long-term pastures that have developed over many years, is kind of what we were looking to do. And if you look closely at this, but I'd like you to just note that there are a lot of different types of roots and a really thick content of roots right through this whole 30 centimetres plus of the root horizon. So here, this is, I'm pretty sure, sandfoin. So you can see that that's where it was sitting in the soil. It's coming right through. If we work our way into it here, we can see, look, there it is, and it's still on the way down. There's the cut end, so that was still going further down. So we've got lots of species that are giving you this depth. We've also got the very fine species, so we've got a number of different clovers and other forage legumes. Each of those have got a very slightly different root structure and a slightly different expectation in terms of how far it goes. So look here, this is one of those clovers which is giving you quite a thick fleshy root. These very fine fibrous ones are due to grass roots of one kind or another. Unless I actually follow them through, I'm not sure exactly which ones are which. You can see here, here's one of these lovely big fleshy chicory roots. We know that Dactylus or cocksfoot is one of these tussocky root grasses, so that gives you a very big root ball, and indeed will go down quite deep, and it's pretty drought tolerant. And in some of the later mixtures you'll find sort of cross species like Festulolium, which are especially deep rooting and very drought tolerant. We can still see quite a lot of roots right down. Now we're a good sort of 5 or 10 centimetres into the clay layer, and again you can see all of these roots penetrating right down. And I think that's really important, because if these deep large roots get down into the subsoil horizons, that helps with the whole soil forming improvement and process, and it means that as they break down, when he returns to arable on this field, you've got potentially, as that organic matter starts to break down, you have improvement in soil health in a slightly longer term way. And you've got injection of nutrients in those lower soil horizons. And of course, if you've got a difficulty with your arable crop, be it wheat or barley or whatever, penetrating into these lower horizons because of the heaviness of the subsoil, if you've got this being opened up, and as those roots begin to decay, then you've got potentially many more fissures and gaps whereby the wheat roots and the barley roots can find their way down and pick up all sorts of nutrients in the lower soil horizons, which they wouldn't necessarily be able to get to otherwise.
So as Lydia was describing, you've got a lot more roots in your ley treatments than in your arable treatments, and you've got particularly in the herbal treatments, there are a lot of different kinds of roots. So one of the key questions we have is, what kind of effects are these having on soil structure? And to answer that, what we've been doing is taking undisturbed soil cores from both assessments and slicing them down into 5 centimetre increments. And from that we'll get some pretty accurate inferences about what effects these crops are having on bulk density and porosity and so on. And ultimately some of these cores will go to the University of Nottingham as well, where they have a very high-tech piece of machinery called an X-ray tomography, and that's a computer assistant X-ray which essentially just like an X-ray in a hospital, it scans the entire soil core, and the computer software then flags up differences between soil particles, the gaps between soil particles and organic matter, i.e. the roots as well. Because that's the key for soil structure really. What you're really talking about is the distribution, the shape, the size, the connectivity, the tortuosity, all those things of soil pores. And we want a soil structure that has, you know, a spectrum of those kinds of parameters, which is conducive for crop production, i.e. which is not compacted, or which is not so loose that all the water and air passes through it and doesn't really allow microbes to grow and roots to grow, and so on. And also what this will do is give us an indication of what kind of carbon is going into the soil. So you've got two kinds of key inputs. You've got the soil organic carbon and you've got the root carbon as well. We're going to try and be looking at both of those to see what is the potential for carbon sequestration in ley farming, and how much can arable farmers expect to increase soil organic carbon in their ley periods, which obviously is integral for soil quality and for crop production, but it also has that climate implication as well. When we look at the effects on soil structure, one of the key things we're looking at is, are we seeing changes in density in the horizon between topsoil and subsoil here? So you can see really clearly here, you've got this line, and that indicates where the next horizon starts, and obviously it's a lighter colour because it's much lower in organic matter then. And we'd really like the water falling, rainfall falling, to percolate down through this at a speed that is conducive for crop productivity as well, and that's contingent on the density and the porosity and so on. So in our assessments we're looking to find out, is there changes in the structure along this line, and are those changes conducive for crop production the following year. So here I am now in the arable part of the pit we've just dug, and this is obviously the wheat field. It's adjacent to our Herbal Ley here. This has never been in a ley treatment before, and it's just pure arable soil. As you can see, the structure here seems to be actually pretty good. I think Jeremy's doing a good job on this farm. Like, you can see if I take a kind of a clod off like this, because it doesn't have the network of roots and because it doesn't have the root exudates holding everything together, it really will just crumble apart like that in my hands, which obviously makes it a little bit more susceptible to soil erosion, and obviously won't really hold the moisture to the same extent that a ley period will. And if I move over here, you know, you pull off a big clod like this off the root structure, and it doesn't come apart really as easily. It comes apart in these big clods like this, and you can see the natural fracture lines like this. And this is because obviously all the different kinds of roots are holding it together, and also the root exudates are like a glue that holds it together as well. And we're hoping to show that this will benefit crop production going forward in the future.